This is the internal architecture. I hope you can see the slide. Okay. At the heart of, please pay attention now. Okay. So at the heart of the microprocessor architecture, now what we are trying to study over here is the how is it implemented inside the chip or inside the silicon wafer. Okay, how the 8085 or the microprocessor is inside. Okay, what is the circuitry inside the silicon chip, basically. So all microprocessors above the 8085, for example, the 8086, for example, the 80386, for example, Pentium above, okay, they are different from this, but the basic architecture is always the same. So hope we will study the internal architecture of the 8085, and then we can make a comparison with all other microprocessors. So what might be the difference? We can observe gradually. Okay, first come first, at the heart of the microprocessor, the very most important combinational circuit. Okay, the most important combinational circuit is the ALU. Is the ALU. I will draw it in the blackboard, whiteboard. So for that purpose, actually, खुले जाओ है त्यसपछि हामी चाहिँ सो खुल्दै जाउँ त्यसपछि म यसमा ड्राइङ पनि गरौँला अहिलेको लागि चाहिँ स्लाइडबाट नै डिस्कसन गरौँ हैन सो ALU is basically a combinational circuit. The 8085 or all microprocessors, they are what we know, they are clock based circuits. Clock based circuits, that means they are sequential circuits. They have a state of the circuit, etc., etc. But this part, the ALU, the arithmetic logic unit, it is a combinational circuit and it contains various circuitry. For example, it contains the adder circuitry. For example, it contains the subtractor circuitry. For example, it contains an array of AND gates, array of NOT gates, array of let us say XOR gates, and it contains multiplier circuitry, etc., etc. So it is basically a combination of several circuitry inside, and it is a combinational circuit. So it does what? It either adds, it either subtracts, it multiplies, it transfers, it stores data. Does not store data. It transfers data. It performs logical operations, etc., etc. So that is the ALU. In the bracket, what has been written is 8, which means that it is of size 8. It is of size 8-bit. Everything inside the 8085 is of size 8-bit. Everything inside the 8085 is of size 8-bit, including the data bus, including the registers, including the ALU and everything. So everything is of 8 bits. Now, I just told you that the ALU performs additions. It performs subtractions. So for all these operations, it needs 2 operands at least. In the least, it needs 2 operands. So you can see these 2 arrows over here. Okay. So you can see these two arrows, this one and this one. Okay, these two arrows are, that means it is a set of 8 data lines. It is a set of 8 data lines from the register accumulator, from the accumulator register to the temple and to the ALU. Okay, the first operand is the accumulator, operand number 1. For example, when we write an instruction add uh, 2, A. La camera. So it might be a typical instructions add 2, A or add A, 2. That means we are adding the contents of accumulator A with 2. So we have 2 operands. The accumulator A is over there. You can see the first operand, and the second operand is in a temporary register. It is inside a temporary register, and it is also an 8-bit register. The value other operand will be over there, and these two will be carried over to the ALU and added by the ALU. Okay, the final result will be placed back again once inside the accumulator A. The final result will be placed back once again inside the accumulator A over here. For example, the data will flow from here. Okay, the data will flow over here. The result 2 plus A, let us say A contains 4. Okay, so it will come back once again to the accumulator. So accumulator is a program visible register. Okay, it is a program visible register. What I mean by program visible register is that programmers, they can what? They can use these registers in your own programs. So accumulator is the most important register among all registers for you programmers and for the microprocessor as well. That means the majority of operands, okay, they pass through the accumulator. All the results of all operations, they are stored in the accumulator. So accumulator is an important register here. It is operand number 1. Now, second thing is that needs to be discussed is the 8-bit this is the internal bus. So we were talking about the system bus in our previous discussions. System bus in our previous discussions, which consisted of let me ask a question to Vivek Ban.
Yes, sir.
System bus भित्र कुन बसहरू हुन्छन् त? हामीले जुन सिस्टम बस डिस्कस गर्थ्यौं त्यसमा कुन बसहरू इन्क्लुडेड छन्? अहिलेसम्मको डिस्कसनमा हामीले सिस्टम बस भनेर भनिरहेको थियौं, त्यसमा कुन बसहरू इन्क्लुडेड छन्?
Address bus.
Yes, address bus. Makalu bus, Agni bus, address bus, data bus, and control bus. Address bus, data bus, and control bus. तो मेरो छोरीलाई याद भइसक्यो है. विवेक बन मेरो छोरीलाई याद भइसक्यो. एड्रेस बस, डेटा बस और के रे control bus. So सो यो जुन मैले अहिले हाइलाइट गरेर यो फिगरमा देखाएँ यो जुन बस छ यो सिस्टम बस होइन इट इज द इन्टरनल बस that is implemented inside the silicon wafer of the 8085 जुन 8085 चिप छ 8085 चिप भित्र इम्प्लिमेन्टेड गरिएको हुन्छ प्लिज नोट यहाँ चिप भित्र जति पनि यो प्यारालल लाइन्सहरु इम्प्लिमेन्ट गरिएको हुन्छ प्यारालल लाइन्सहरु इम्प्लिमेन्ट गरिएको छ दे आर इम्प्लिमेन्टेड एज wires by high doping or sometimes and nowadays they even deposit layers of aluminum inside the silicon wafer to implement यो मैले अस्ति भर्खर देखेको भिडियो हो that is addition to my knowledge अस्तिसम्म मैले के भनिरहेको थिएँ भन्दाखेरि चिप भित्र जुन कन्डक्टिङ पाथहरु इम्प्लिमेन्ट गरेको हुन्छ त्यो डोपिङ कन्सन्ट्रेसन हाई गरेर इम्प्लिमेन्ट गरेको हुन्छ भनेर भनेको तर हिजो भर्खर मैले फेसबुकमा एउटा भिडियो शेयर गरेको छु तिमीहरुले हेर्यौ कि हेरेनौ त्यसमा चाहिँ सिलिकन वेफरहरु कसरी इम्प्लिमेन्ट हुन्छ कि हुँदैन भनेर हिजो हैन अस्ति 2-3 दिन भयो के सिलिकन वेफर भित्र कसरी इम्प्लिमेन्ट गरिन्छ भनेर त्यो चाहिँ द म्यानुफ्याक्चर प्रोसेस अफ एन आईसी भनेर भनेको थियो र त्यसमा चाहिँ जति पनि कन्डक्टिङ पाथहरु छ यिनीहरुमा एल्युमिनियमको थिन लेयरलाई डिपोजिट गरेर सिलिकन वेफर भित्र एल्युमिनियमको थिन लेयरलाई डिपोजिट गरेर बनाइन्छ भनेर जे होस् हाम्रो यो 8085 भित्र 8085 भित्र के हुन्छ भन्दाखेरि 8 बिट इन्टरनल डेटा बस हुन्छ जसमा सबै जनाले आफ्नो डाटा पठाउँछ या त्यहाँबाट रिसिभ गर्छ फर एक्जाम्पल एक्युमुलेटर यु क्यान अल्सो सी कनेक्टेड टु द 8 बिट इन्टरनल डेटा बस टेम्पोररी register also everything is connected to the 8 bit internal data register bus the results are also being placed back into the 8 bit internal data bus okay enough for that for the time being now we'll talk about this we'll talk about this part we will talk about this part which is called what the register bank the register bank so register bank भनेको के हो जहाँ केही चीजको कलेक्सन okay so here is a collection of registers several registers you can see the names written over there W Z B C D E H L what are these are the names of the registers and among these registers W and Z are program invisible that means you cannot write them in your program but B C D E H L they are what program visible registers you will be using them in your programs exhaustively okay and you can see that all these registers B C D E H L are what they are 8-bit registers they are 8-bit registers individually but the combination of this that means B and C together B and C together is a 16-bit register okay you can address this BC register together as a 16-bit register as well okay BC एकैचोटी BC भनिदिनु पर्छ okay similarly DE is together a 16-bit register while individually these are 8-bit registers HL it is together a 16-bit register while individually it is an 8-bit register ठीक छ यहाँ माथि मल्टिप्लेक्सर दिएको छ मल्टिप्लेक्सर किन दिएको छ भन्दाखेरि डिकोडर हो त्यो डिकोडरले के गर्दिन्छ त यो एउटा रेजिस्टरलाई एड्रेस गरिदिने काम गर्छ हैन एज पर ऑपरेंड एज पर इन्स्ट्रक्सन कुन चाहिँ रेजिस्टरलाई एड्रेस गर्नुपर्ने हो त्यो रेजिस्टरलाई एड्रेस गरिदिन्छ यु क्यान कन्सिडर दिस रेजिस्टर बैंक एज अ स्मल मेमोरी दैट हैज बीन इम्प्लिमेन्टेड इनसाइड द सिलिकन चिप ठीक छ कुरो बुझ्यो सो यो रेजिस्टर्सहरुको इन्डिभिजुअल पर्पसेसहरु पनि हामी डिस्कस गर्छौं हैन अहिले एकछिनमा अहिलेको लागि के बुझ भन्दाखेरि दिस आर रेजिस्टर्स रेजिस्टर्सको पर्पस तिमी याद राख के को लागि हो भन्दाखेरि अब BCDEHL रेजिस्टर्सहरुको पर्पस के हो भन्दाखेरि यो प्रोग्राममा तिमी युज गर्छौ फर राइटिङ फर कीपिङ भेरियस डाटा for implementing various variables etc but the temporary registers यिनीहरु के को लागि गरिन्छ भन्दाखेरि यो रेजिस्टर्सहरु रफ वर्क को लागि हो जस्तै तिमीहरु बच्चामा स्कुल जाँदाखेरि लेट अस से सानसानो एडिसन गर्दाखेरि पनि पहिला रफमा एडिसन गर्थ्यो लेट अस से 4 डिजिट को एडिसन गर्दाखेरि रफमा एडिसन गरेर बल्ल आन्सर लेख्थ्यो हैन त्यो रफमा एडिसन गर्ने काम रफ वर्कहरु सबै चाहिँ कहाँ गरिन्छ भन्दाखेरि टेम्पोररी रेजिस्टरमा all temporary results are placed in temporary registers. So we have 3 temporary registers, one directly attached to the ALU as operand number 2 and 2 in the register bank, one is W and Z. Okay. ठीक छ यहाँसम्म कुरो बुझिरहेछ ओके विकासनाथ योगी विकासनाथ योगी खै त विकासनाथ योगी विकासनाथ योगी okay Vikasnath Yogi is being kicked out of the meeting. Dipesh Adhikari. Dipesh Adhikari.
Yes.
कति कुन रेजिस्टरको नाम लिए मैले भने त अहिले Please tell me the name of it with registers that I had just mentioned.
Temporary.
Of temporary registers. मैले अहिलेसम्म इन्स्ट्रक्सन रेजिस्टरको नाम भनेको छैन रेजिस्टर ब्याङ्क भित्र कुन रेजिस्टर्सहरु छन् त्यो भन्दै त
W.
Okay, then
HL.
HL. Okay, I have mentioned them till now. Okay, ठीक छ अब म डिस्कस के गर्दैछु भन्दाखेरि stack pointer. There is another register inside the register bank called stack pointer. What is this stack pointer basically? First of all, I must explain what is a stack. First of all, I must explain what is a stack. So, you have been studying data structures, you have been studying C++, C, etc. till now. A stack is basically a memory, sort of pile, you can understand. Okay? थाक लागेको जस्तै फर इक्जाम्पल तिमीहरू अस्ति मैले इक्जाम्पल दिएको थिएँ 4 वर्षमा जतिवटा सब्जेक्ट पढ्छौ र त्यसको सबै बुक्सहरुको एउटा थाक लागेर एउटा ठूलो थाक लाग्यो भने that would be the stack. So basically on all such stacks, what you can do, either you can take out a book from the top of the stack, or you can place a book on top of the stack. Okay? बिचमा केही तानतुन गर्यो भने कि त पुरै स्ट्याक ढल्छ है कि त पुरै तिम्रो स्ट्याक ढल्छ है अथवा के हुन्छ भन्दाखेरि गाह्रो हुन्छ कहिले सकिदैन पनि कतिपय स्थितिमा सो स्ट्याक इज अ हामीले दुई किसिमको पढ्यो शब्द one is a RAM, okay, one is a RAM, random access memory भनेर हामीले पढ्यौ है र अर्को के पढ्यौ त हामीले स्ट्याक भनेर पढ्यौ random access memory लाई यो नाम किन दिएको भन्दाखेरि because you can access, suppose we have a 1 KB of memory, there will be 1024 memory locations in 1 KB memory, so you can access any one out of the 1024 memory locations individually randomly हैन 1024 वटा मेमोरी लोकेसन मध्ये कुनै एउटा मेमोरी लोकेसनलाई र्यान्डमली कुनै पनि बेला हामी एक्सेस गर्न सक्छौं त्यसैले हामीले त्यसलाई के भन्छौं र्यान्डम एक्सेस मेमोरी बट इन अ स्ट्याक if a certain portion of the memory is implemented as a stack then only the top of the stack will be visible, only the top of the stack will be visible, not even the contents, only there will be just a pointer to the top of the stack. There will, for example, let us say this is memory. Right? These are several memory locations. And let us say this part is a stack. Let us say this part is a stack. So if this is a stack, then there will be a single pointer to the tip of the stack. There will be a single pointer to the tip of the stack. Only this particular memory location will be visible, will be addressable. And you cannot extract you can either remove this item, in which case the stack will become smaller, or you can add a new item to the top of the stack. You can add a new item to the top of the stack, in which case the stack will grow bigger. Okay, so at that time the stack pointer will point to this point, which will become the new top of the stack, Understood? So stack easily can be empty. The stack can grow. The stack can decrease or shrink in size, but only the top of the stack will be addressable or can be pointed through the stack pointer that we were just discussing. Okay, through the stack pointer. Okay, so stack pointer is basically a register which contains the address to the top of the stack. Okay, you can either pop items from the stack. Pop means remove an item from the stack, and in which case the stack will become smaller, or you can push an item to the stack. That means you can add a new item to the stack or new content to the stack, in which case the stack will increase or expand in size. Okay, so that's all about the stack. And at this point, you must understand that it is a register that contains a 16-bit value, which is an address. Remember, all addresses are 16-bit addresses. Why? Because the address bus is 16-bit. The address bus is 16-bit. See over here. Here are two buffers. Right? यहाँ दुईटा बफर देखाइरहेछ एड्रेस बफर 8 अर्को data slash address buffer 8 भनेर देखाइरहेछ. What is this? Why two buffers have been? What is a buffer? First of all, what is a buffer? What is a buffer? Can somebody tell me? Can somebody tell me? Let us say Lijesh Subedi.
Yes, sir.
What is a buffer? अस्ति सायद तिमी सिडी सेक्सनको हो लिजेश सुवेदी?
म एबी को सर.
ल भन त बफर भनेको के बुझ्याछ तिमीले?
बफर भनेको कुनै कुरा चल्नु भन्दा अगाडि एकछिन टाइम लाग्ने टाइम.
बफर टाइम. ओके, युट्युब बाट तिमीले त्यो आन्सर बताइरहेछ हैन? युट्युबमा मतलब तिम्रो भिडियो चल्नु भन्दा अगाडि केही छिन प्री लोड गर्दाखेरि जुन टाइम लाग्छ त्यसलाई बफर टाइम भन्छ र प्री लोडिङ प्रोसेसलाई चाहिँ बफर भन्छ भनेर त्यसरी बुझ्यो. Okay, so you may be partly right over here. You may be partly right. It is buffer is something related to streaming. Okay, that's good. Okay, but in this context, not very right. Kajal Singh, any idea what is buffer? Kajal Singh.
Okay.
Any idea what is a buffer?
Buffer contain data that is stored for a short amount of time.
Yes. Buffer contains data that is stored for a certain amount of time. This is only half true. Okay, this is only half true. Buffer is basically used in all जहाँ पनि ट्रान्समिसन गर्नुपर्ने छ, एक ठाउँबाट अर्को ठाउँसम्म पठाउनु पर्ने छ, त्यहाँ हामी एउटा रेजिस्टर राख्दिन्छौँ जसलाई हामी बफरको नाम दिन्छौँ. Okay, so let me draw that for you. Let us say source butter destination somewhere, right? This is source, and there is a wire from source to the destination. This is, let us say, TX, and let us say this is RX, right? अब यो एउटा तार हो, यो के हो त, यो एउटा तार हो। कुनै पनि तार भनेको के हो, कपर मिडियम या एल्युमिनियम मिडियम या गोल्ड मिडियम या सिल्वर मिडियम, whatever medium has a very good conductivity but has a resistivity as well, has a resistance as well. So this resistance causes loss of energy, and as a result of which a 5 volt that you might transfer will reach the other end as, let us say, 4 volt or greater than 4 volt or 3 volt or whatever, but lesser than 5 volt. That is true. That is true. So there will be attenuation in any transmission line. There will be attenuation in any transmission line, but a TTL compatible logic requires that a logic 1 will be decoded as if it is 5 volt. If it is 5 volt, then it will be logic 1, and if it is 0 volts, then it will be logic 0. So that is TTL logic. But what we have is that the voltage is decreasing due to the attenuation process. So what we need is an amplifier. In any transmission line, what we need is an amplifier. Okay, number 1. And we also might need to store the data for a certain time. जबसम्म अर्कोले read गर्दैन, let us say if RX is a slow device, the other end is slow in receiving, then what you might say is that this data needs to be held on to the line for a certain time. So basically, what you can say, this is a combination of latch plus amplifier. Okay, latch plus amplifier. So this would be what we understand as buffer. Buffer is basically a register in any outgoing or incoming transmission line where the data needs to be latched as well as amplified. So it is a combination of latch and amplifier, and you can see these buffers. Just for example, हामी register bank में जति registers छ उनीहरुलाई register भनिरहेछ, तर यही address buffer bus को अगाडि जोडिएको registerलाई चाहिँ हामी buffer भनिरहेछ हैन। किन यो फरक भन्दाखेरि because buffer is something related with transmission. Please mute your microphone. Okay, so buffer is related something with transmission. Okay. So यो पार्ट पनि मैले एक्सप्लेन गर्दिए। सो अब यहाँ के छ त, दुईटा हामी देखिरहेछ बफर्स, एउटा 8 बिट एड्रेस बस A8 देखि लिएर A15 को लागि र अर्को डेटा एड्रेस बफ AD0 देखि लिएर AD7 को लागि। Okay, now so we were back to the point of stack pointer. So stack pointer is a register, a 16-bit register. Why? Because addresses are 16 bits and it contains the address of the top of the stack. So we implement the stack through the stack pointer. Okay, finally we have a program counter. What is a program counter? It is a very, very important register. Okay, it contains the address of the next instruction to be executed. Please note this, program counter, it contains the address of the next instruction to be executed. Richa Pokharel. Okay, what did I just say? I talked about program counter, and I said that the program counter does something, or stores something. What does the program counter store? What does the program counter store? खै त कहाँ ध्यान हुन्छ तिमीहरूको यसरी नै तिमीहरूलाई म प्रोग्राम काउन्टरले के स्टोर गर्छ के गर्दिने त तिमीलाई रिमुभ फ्रम मिटिङ गर्दिने रिचा पोखरे should I should I remove you from the meeting should I remove you from meeting okay please pay attention the program counter contains the address of the next instruction to be executed okay the current instruction is being executed continuous present the current instruction is being executed while the next instruction is that which is to be executed after the current instruction the address of the current instruction will be stored in the program counter while the current instruction is being executed okay हुन्छ सो हामीलाई करेन्ट इन्स्ट्रक्सन को साइज बाट हामीलाई के डिटरमाइन हुन्छ त प्रोग्राम काउन्टरले करेन्ट इन्स्ट्रक्सन को एड्रेस बाट र करेन्ट इन्स्ट्रक्सन को साइज बाट नेक्स्ट इन्स्ट्रक्सन को एड्रेस के होला भनेर एडिसन सिम्पली इन्क्रिमेन्ट गरेर पत्ता लगाउन सकिन्छ फर एक्जाम्पल इफ द करेन्ट इन्स्ट्रक्सन इज एट 0001 then the next instruction will be at let us say 002 or 003 or 004 तर यो सिम्पल एडिसन इन्क्रिमेन्टेसन हो र त्यो इन्क्रिमेन्ट र डिक्रिमेन्टले गर्छ सो प्रोग्राम काउन्टर कन्टेन्स द नेक्स्ट इन्स्ट्रक्सन टु बी एक्जिक्युटेड तिमीहरू एटेन्टिभ छैन भनेर म प्राय एउटा सेन्टेन्स 3 चोटी 4 चोटी भन्ने गरिरहेछु है र त्यो है सो दैट you do not miss the point okay so this is all about the registers in the register bank we have this BCDEHL program visible register WZ program invisible registers stack pointer to implement the stack the top of the stack is pointed program counter the address of the next instruction is contained okay now we have out of the register bank we have a register called instruction register we have a register called instruction register okay I will use a different color now so this is the instruction register it is a 8-bit register and what does it do just like the program counter it does not contain any address why because it is not an 16-bit register all registers that carry addresses are 16-bit registers while all registers that carry simple data are 8-bit registers remember that okay so the instruction register carries the current instruction being executed so कुनै पनि instruction लाई execute गर्नु छ भने कुनै पनि instruction लाई execute गर्नु छ भने मेमोरी बाट बोकेर लिएर आएर कहाँ राख्नु पर्छ त instruction register मा राख्नु पर्छ that is called the fetch process fetch instruction fetch okay so the destination of the instruction fetch is instruction register from the memory main memory to the instruction register so instruction register carries the current instruction being executed the instruction register carries the current instruction being executed म दुई चोटी भन्छु तेस्रो चोटी पनि भन्दैछु the instruction register carries the current instruction being executed Karan Raut
Yes, sir.
what does the instruction register do
Carries the current instruction being executed.
Thank you very much okay okay so you can see that the instruction register is connected to another block that is called instruction decoder and machine cycle encoding so this I can shortly call as decoder this is the decoder that means this instruction this force block decodes the instruction the current instruction once it has been fetched it has to be decoded that means what does this binary bit combination mean we know all instructions are stored as opcodes okay it is stored as a combination of or a unique combination of ones and zeros all instructions so they have to be first decoded what does it mean just say for example हाम्रो दिमागमा एउटा डिकोडर छ जसले नेपाली बोल्यो भने के बोल्यो भनेर थाहा पाउँछ तर चाइनिज बोल्यो भने के बोल्यो भनेर थाहा पाउँदैन हैन अंग्रेजी पनि हामीलाई आउँछ त्यो डिकोडरले अंग्रेजी बोल्यो भने पनि थाहा पाउँछ तर एउटा चाइनिज मान्छेले बोल्यो भने त्यसलाई ट्रान्सलेटरले एक्सटर्नली ट्रान्सलेट गरेर दिनुपर्छ। तर त्यसै गरी 8085 को एउटा इन्टरनल ट्रान्सलेटर हो डिकोडर, जसले के गर्छ भन्दाखेरि उसको मातृभाषा अपकोड या मसिन ल्याङ्ग्वेजलाई के बोलिरहेछ भनेर दिमागमै के गरिदिरहेछ त उसलाई अन्डरस्ट्यान्ड गर्न हेल्प गरिदिरहेछ। सो डिकोडर डिकोड्स द इन्स्ट्रक्सन, decoder decodes the instruction. So once it has been decoded, once the instruction has been decoded, then it will understand whether it is doing it. The operation to be performed is either an addition, or the operation to be performed is either an subtraction, or the operation to be performed is either a data transfer or logic operations. And based on the operation, certain control signals will have to be generated. For example, if you need to access the memory, then you need to generate the read signal, and IO/M is equal to 0. Yeah, right. So we have another block. Timing and control, and this is connected to the decoder. So the timing and control will generate all the control signals of the control bus. It will generate all the control signals of the control bus based on what is the current instruction, or what the current instruction wants the microprocessor to do. For example, if the instruction is move, if the instruction is a move instruction, it means move from memory. That means we need to access the memory. Similarly, if the instruction wants to transfer data to the memory, then we need to activate the write signal, and we need to that means IO/M will become 0. Similarly, if the address is being generated, the ALE is required. Similarly, the status pins S0 and S1, they are also activated. For example, during instruction fetch, we know that S0 S1 IO/M S0 S1 has a combination of 0 1 1. And 0 1 1 हामीले अस्ति पढेको थियो त्यो एउटा टेबल जस्तो छ। सिमिलरली सबै कन्ट्रोल बसहरू चाहिँ यो टानीको टेबलमा आइरहेछ भनेर चाहिँ हामी यहाँ देख्न सक्छौँ। सो इट इज कनेक्टेड टु द डिकोडर। जसरी टाइमिङ एन्ड कन्ट्रोलरले सबै हाम्रो कन्ट्रोल बसहरू कन्ट्रोल सिग्नल्सहरू जेनेरेट गर्छ, त्यसैले एउटा इन्टरप्ट कन्ट्रोलर पनि छ। इन्टरप्ट कन्ट्रोलर माथि देख्न सक्छौँ हैन, इन्टरप्ट कन्ट्रोलर पनि माथि देख्न सक्छ, जसमा सबै इन्टरप्ट सिग्नलहरू रिसिभ गर्छ र त्यसै अनुसार तिनीहरूलाई ह्यान्डल गर्ने काम इन्टरप्ट कन्ट्रोलरले गर्छ। त्यसैले सिरियल डाटा ट्रान्सफरलाई पनि सिरियल कन्ट्रोलरले ह्यान्डल गर्छ। ठिक छ, कुरो बुझ्यो? सो दिस इज अल अबाउट द आर्किटेक्चर अफ आवर 8085 है। समराइज इट अल, एएलयू हुन्छ जसले सबै अपरेशन्सहरू गर्छ। ओके, इट इज द वान व्हिच परफर्म्स द अपरेशन्स। ओके, we have some program invisible registers. Okay, one of them is an operand 2. Okay, temporary registers, they are not visible to the programmer, but they are used to do some rough work or store the temporary results. Accumulator is the most important or the most commonly used register. Okay, in the 8085 with all instructions, the accumulator is always used. Similarly, we have other registers B, C, D, E, H, L. Okay, we have program counter, we have stack pointer. Program counter carries the instruction of the next instruction to be executed. Stack pointer points to the top of the stack. Similarly, instruction register contains the current instruction being executed, and the decoder decodes it. Okay, that's all about the summary of the internal architecture of the 8085. Okay, now we move on to the description. हैन, अहिले सबै डिस्क्रिप्सनहरु मैले अघिकै डिस्कसनमा गरिसके। यो मैले धेरै डिस्कसन गर्नु पर्दैन होला, तर पनि म सरसर्ती यो पढ्दैछु। Arithmetic logic unit, a combinational circuit that performs the basic computations as per instructions. Okay, that's fine enough. A good definition. Accumulator, a program visible register that always contains the first operand to the ALU and the results of the ALU. Okay, the second operand is placed in a program invisible temporary register. Okay, program visible register BCDEHL. Okay, BC is a 16-bit register together, while B and C are individually 8-bit registers. Similarly, DE is a 16-bit register together, while D and E are 8-bit registers individually. HL is a 16-bit register together, while H and L are 8-bit registers individually. Okay, invisible registers, stack pointer contains pointer to the tip of the stack, a special area in the memory with a special purpose. Okay, very good. Program counter, instruction register. Okay, instruction decoder. You